Okay? There will be one indirect proof. There you go, one indirect proof. The difficulty of it, who knows? I can tell you it won't be a simple one. Will it be the level of number 6 or 5 or 6, whatever that last one was last night? Probably not, but it'll definitely be somewhere in between. If you want to practice for indirect proofs, it's all in your packet. Okay, all in your packet. Speaking of your packet, because I'm going to go to it here in a minute, make sure you're on page 34 for me, because I'm going to go to that sooner or later. All right, ready? Here's the deal for the test. First 6 questions. I said 7 yesterday, I misspoke. First 6 questions. Fill in the blank for me. The intersection of all 3 medians is called the blank. You got to fill it in. And it's right or wrong. There will be a word bank at the bottom, but can we be honest with each other? What the heck's a word bank going to do for you other than spell it correctly? If you don't know it, you're not going to see it in a word bank and know it then as well. All right, so other than spelling it, that's about all the work the word bank's going to have to do. And by the way, there's more words in the word bank than there are questions, so it's just not process of elimination. All right, so that's the first 6 questions. What am I trying to tell you? Know your darn vocab. Okay, know your vocabulary before the quiz. Using 3 triangle inequality theorems. Let's talk about all 3 right now. First one. I'm going to start it. Somebody in here is going to finish it. If you have to look back in your notes, please do so. An exterior angle of a triangle is, all right, let's finish the theorem for me. From this unit, don't tell me that it's equal to the sum of the 2 remotes. That was last unit. We went a step further this unit and said, all right, if they're equal to the sum of the 2 remotes, then one exterior angle's got to be, look back if you need to. That's how we're going to study for it. Remember it better. 13, one exterior angle of a triangle is? It has something to do with an exterior and the remote interiors. From unit 4, we said add the 2 remotes and it's equal to the exterior, but this unit we took it a step further and said the exterior has to be greater than the remote interiors. There we go. There's theorem number 1 that's going to be applied somehow on Monday. Something in a question form. Number 2, angles and sides. Tell me about them in a triangle. Angles and sides. Relationship, angles and sides. What about them? They're in a specific spot. 21, what do you know about angles and sides? I have no idea what you're saying is my response. 2 congruent angles. Okay, let me lead you. Biggest angle. Where is it? Always across from? That's what I'm looking for. Everyone, yes? Biggest angle in a triangle? And I'm being tough here, guys, today, because I need you to know before you walk out, shoot, I need to start studying this topic a little more. Biggest angle across from biggest side. And you can substitute in the word smallers if you like to. Okay? Last one. This is what we did with the licorice. You cannot have a triangle with any 3 side lengths you want. It has to follow what theorem? 8. It's got to follow?
The sum of 2 of the sides has to be greater than the third.
Perfect. Sum of 2 sides must be greater than the third. Will you have to write out these theorems for me? No, but you're certainly going to have to apply them. And you'll see how in a minute here when we start practicing. So there are the 3 triangle inequality theorems from this unit. Anything you'd like to ask before I move on with topics? All right. I just want to let you know there's going to be a question where I'm going to give you a diagram. That's made up of two triangles put together. And I want to know from shortest to longest, please rank the sides. If you guys have your packets open, take a look at 2 and 3. That's what I'm talking about. Okay, that's exactly what I'm talking about. We will do those in a second, by the way. At least number 3 we'll do in a second. But that, everyone good? That's what I'm talking about. Rank the sides from shortest to longest in that diagram. Okay, this next topic we have not covered since before the quiz. And because we've had Thanksgiving break, it's been a while. Partitions. Take a segment, break it up into a ratio of 2 to 3. Where's the point? Break it up into a ratio of 1 to 2. Where's the point? 3 to 7. Where's the point? Ready? There's no practice in your packet or in the textbook for this. So I got you. I got your back. I have your back. On Classroom. You're right there right now. Everyone sees unit test extra review. Unit test extra review right underneath the topics. One of those files is partitions. A whole slew of partition questions for you guys if you need it. Also in there, while we're here, if you want to work on any of those theorems, there's questions here. And points of concurrency. So orthocenter, circumcenter, centroid, incenter. If you want to work on any of that, it's there as well. Okay, so more stuff for you than the packet and textbook. Because you will not see any partition questions in your packet. None. None. They're all right here on the extra review. All good? Any questions here? I always try to hook you up with more than what's in the packet. All right, next up, inscribe versus circumscribe. I will ask a question about that. So let me just, I Googled and clipped a couple images for you. Is this first circle inscribed or circumscribed about the triangle? This first circle right here, is it what I consider that an inscribed or a circumscribed circle? Good thing we're reviewing, huh? Inscribed or circumscribed, that circle? Inscribed, because it's inside, right? It's inscribed, inscribed circle. Now here's another follow-up question. What's that point called? The center of that circle that's inscribed. That's inscribed. It's called the incenter, correct. And then my next diagram, that circle is not inscribed, it's circumscribed around the triangle. Good. That circle is circumscribed around. Let's just say, I don't know, that's the center here. What's that point called? The point, the center of a circle that can be circumscribed, that's called the circumcenter. Yep. Okay, circumcenter. So please know the difference between inscribed, because there is a multiple choice question on there where this will come up. Finally, centroid algebra. Okay, guys, I'm drawing in a green segment right now. A green segment. What's it called? Median. Good, median. Which means somewhere on here has to be the, where do all three medians intersect? Centroid. So I'm just going to say it's right here. There's the centroid. And probably here's what I'll do for you on Monday. I'll say, hey, this part right here, 3x minus 2. This part right here, x plus 6. Find x. I got to know the centroid rule, right? Got to know the centroid theorem. Is that true? Absolutely not. No. How do you make it true? By using the theorem.
Multiply x plus 6 by 2.
Why by 2? Because the centroid breaks the median up into a ratio of 2 to 1, or this segment is double the length of this segment. Every time. Every time. All right? So there's centroid algebra. Anything up here before we start diving into actual problems? And then you start getting called on. Anything. Packet. Page 34, number 3. Here we go. That's the first one we're going to do. Packet. Page 34, number 3. Take that diagram and please rank the segments in order from shortest to longest. Shortest to longest. Well, I don't even want to talk shortest or longest yet until you know what about this diagram. There's still work to do. What's still got to be done before I start here? 11? Fill in the angles, right? I was going to say, don't shut your Chromebooks down because we're going to go to somewhere else here in a second where you might need them. All right, so yes, fill in the angles for me. Those angles, when you're ready, 13, find the missing angles here for me. Let me know when you get them.
43.
For which angle?
And
Yep, angle N is 43, and the other missing angle, LMO, when you're ready? 38, yep. Now, if you're going to rank the whole diagram, you got to rank both triangles. All right, we have to rank both triangles from shortest to longest first. So I'll give you an opportunity to write it down, then I'll ask somebody. So we're going to rank LMO versus triangle OMN. LMO, first person up. Can you rank LMO for me? Shortest to longest, 23. LMO, go ahead. Shortest side in LMO. Yep.
LN and MO.
L, M, yep. And MO, good. All right, next person, can you do OMN, the other triangle, please? Rank those. 10, want to rank those for us? Hello.
Hi. The shortest one is MO.
Yep.
The second shortest one is MN.
Yep.
And the longest one is NO.
Yep. All right, ready to rank them. Let's start with the shortest side overall. Shortest side overall. Well, it can only be 1 and 2, right? It's the shortest side from each triangle. So look, I got LO and I got MO. Which one's shorter? Matt? LO. Why is he saying LO? Look right here. You put MO here, everyone, right? Everyone's got MO here? What's this mean that I got 2 behind it? These 2 are shorter than it. Yeah. So that's why LO has to come first. What's the next side? Should I put MO now? No, look at your rankings. There's still one shorter than MO. What is it? LM. Then I can put finally MO followed by, now I'm down to these 2, MN and NO. Which one's shorter? That's why we rank them. MN is. And then NO. If you want to put 1, 2, 3, 4, 5, 6, great. Go ahead. Be careful. Read this problem carefully on Monday, because there's a little, I don't want to say tricks, all right, but it's not as straightforward as this one. Okay? It's not as straightforward as this one, all right? So just take your time on that one. All good. All right, I'm going to go to the book now. I'm not expecting you to open up your textbook online, but you can at least just keep scrolling through my notes on Classroom. All right, you'll see this problem right here, 5 and 14. This is a true-false question, number 5. True-false. And if it's false, we're going to have to substitute in the correct underlined word. So what do you think? To find the centroid, I find the angle bisectors. And if you got to look back in your notes, so be it. If you get called on and don't know it. To find the centroid, do I find the angle bisectors? And we've actually talked about centroid already today. 17, true or false?
False.
Correct. I do not find the angle bisectors. Instead, I'm going to find the what for the centroid? 11, what do I find instead? There you go. And hopefully you guys noticed no constructions on there Monday either. Okay, no construct. I've already quizzed that on the past quiz, so you're good. Questions on 5? 14. I'll just read through all this backstory here, but look, I got 3 baseball players, and they formed a triangle as they're warming up. There's a 4th player that comes in, and they're basically like, look, I want to stand somewhere so I'm the same distance away from these 3. Where should they stand? Not where, don't come up here and point where they should stand. What's the point going to be called where they should stand? That's what I'm asking for. So again, a 4th player is going to come in here to practice. That 4th player wants to stand somewhere the same distance away from all of the other 3. At what point should they stand? That's what I'm asking for. At what point should they stand so they're the same distance away from all 3 players? What is that point called that is all the same distance away from all 3 players? 2? Good job, Matt. Circumcenter. The point that is equidistant from the vertices. There you go. Well, good. Questions? All right. What's my next one on the list? 28 and 29. I have a triangle, everybody, that has side length 5 feet and a side length of 7 feet. What's the range of possible third side? Just tell me it and I'll write it as an inequality. So what's your possible range of a third side if the 2 sides are 5 and 7? Between what and what? Matt, you already answered a couple times. I'm good. 16, between what and what? 2 and 12. How do you get 2 and 12? You subtract the sides and add them. So 2, I'll put an X, 12. So that third side could be between 2 and 12. And I am going to do it for 29 as well. Now I have a triangle with 4 and 10 and a half length sides. How about the third side here? Third side, 5, possible range, Greg, of third side?
In between 6.5 and 14.5.
Good, I like your vocabulary there. Yep. Anything you want to ask? I know we're grinding here. And then finally, I'm going to skip over this one. I'm going to go to this one. 20, 21, and 22. I'm going to give you 3 angles. You tell me which one's the greater, the biggest one of all 3, based on all your knowledge and theorems this unit. All right, so 1, 5, 6. And we're not going by looks. I want some math, some reasons behind it. So out of 1, 5, and 6, which one do we think has the greatest measure? 1, 5, and 6. Any thoughts? 1, 5, or 6? And again, not because it looks like it. What's up, Jonah?
Angle 1.
You are correct. Okay, he's correct. 1 is bigger than both 5 and 6. The question is why, and what theorem are we using here? Angle 1's what type of angle here? Looks like it's exterior, right? Take a look. Let me show you the triangle we're talking about now, where 1's the exterior. This one right here. Angle 1's exterior. What's 6 then? That would be a remote interior, so we know they're bigger. We just went over that theorem. So 1, that's why 1's bigger than 6. Why would 1 be bigger than 5? Isn't this angle a remote interior too? And what's part of it? What's part of that angle? Angle 5. So if 1's bigger than the whole thing, 1's going to be bigger than the part. So you are correct, Jonah. Great job. All right, it gets trickier. What about out of 9, 8, 3? 9, 8, and 3. Which one's bigger, 9, 8, or 3? Maybe you eliminate one of them because you're like, I know this angle is definitely bigger than that one, so that eliminates one of them. And then compare the other two you're left with. Thoughts? Which one's bigger there? Take a stab at this one. 9, 8, or 3. Hopefully you've narrowed it down to 2 of them, because I think you can definitely tell one angle's bigger than the other. Anybody want to try it out? Sure, go ahead.
9 is equal to 90 degrees, and 3, 7 is, so the sum of 2 and 3 is equal to 7, and 7 is equal to 9, so 8 is greater.
It is. Okay, 8's the greater one. Here's why. Well, first of all, are we all good on why 8's bigger than 3? 8's the exterior. 3 is part of a remote interior. We're all good there? Why I'm eliminating 3 right now. Okay. Now, we're down to 9 and 8. Just let me explain a little bit differently here. So we're done with 3. Now we're down to 9 and 8. 9 is a right angle, isn't it? Which means also what other angle's a right angle? What's another right angle up here? 7. What do you know about 8 and 7? Which one's bigger? 8, because it's exterior. So if 8's bigger than that, 8's bigger than a right angle, isn't 8 going to be bigger than 9, which is also a right angle? Yep. And then finally, maybe this one might be a little easier, I don't know, but 2, 3, 4. Which one's bigger, 2, 3, or 4? They're all interior, it looks like. 2, 3, 4. What's up, Mahmood? You're correct, 4. What type of angle is angle 4? How many? Oh, how many degrees in angle 4? 90. How many degrees in a whole triangle? So if 4 is already 90, is it even geometrically possible that 2 or 3 are bigger than 90? They have to add to 90, don't they? So there's no way 2 and 3 can be bigger than 90 because you can't have 2 angles in a triangle bigger than 90. So that's why, yes, you are correct. 4 is it. Good job. Whew. Hopefully we open some eyes with that review. All right, you know you have the packet, textbook, and extra practice up on Classroom. And everyone does realize that all the answers to your packet and textbook are in here as well. Okay, they're all in here at the end. Choose where you want to go. There's 3 different places you can go. Classroom, packet, or textbook. Okay? Grind all by yourself. All right? Don't move around. Don't even use people in your group. I want you to grind by yourself here. And then use me, call me over if you have questions. This is a pretty strong group, but couple